Let's get back to full screen. There we go. All right, ladies and gentlemen, boys and girls, hello, good morning, welcome. Today's March 27th. This is Algebra 2 CP A6, and today what we're going to be really doing is expanding upon our ideas that we've explored on solving radical equations. We've really taken a look at so far beginner level problems and intermediate level problems. That was really the purpose of last class, was to review those two things. Today, what I'd really like to show you is I'd like to show you a couple of problems that I would consider to be advanced level problems. This is something that I previewed to you in our last class before we took this unexpected break that just so happened to pop up. But I just want to make sure I go through a couple examples with you now in full detail. I ask that if you haven't done so already, please make sure you mute your microphones. Please make sure your webcams are disabled. And if you do have any questions, though, feel free to speak up, unmute yourself, and interrupt me, or just type it in the chat, and we'll be happy to address that, either myself or Ms. Mao. If you want to, in another tab as well, I'd recommend opening up the distance learning assignment, day 2, that I asked you to do. It was just 3 questions this time around. If you have any questions on those, I'd be happy to go over them at the end of class. So hold those questions to the end. But if you would like to see any of those 3 problems, just feel free to let me know. We'll talk about them towards the end. First, though, I really want to explore solving radical equations like this. Like I just indicated, these problems are what I'd consider to be advanced level problems. In that, it's impossible at the very start of this problem to isolate both radicals at the same time. Do you notice that typically before we square both sides to eliminate the radical in an equation like this, we'd like to isolate the radical, just like this one is sort of isolated, but unfortunately this constant stuck onto the end prevents us from doing so. It's either going to be a +1 over on this side of the equation, or if I moved it over to the other side, it's now going to be a -1. So it's really not possible to isolate both at the same time. What we have to do, what we're really forced to do, is we just have to square both sides once to eliminate one of the square roots, reduce our 2 radical problem down to a problem only containing 1 radical, and then go through our process again of isolating the radical, square both sides. It's almost like 2 problems contained within one. So let's go ahead and see what that's going to look like. Again, looking at a problem like this, impossible to isolate both radicals, so we just got to work with what we got. I'm going to go ahead and square both sides. Right? On the right side, the square root and square will cancel out. That just leaves us with 1 minus 8x. Nice and easy on that right side. However, on the left side, if you notice, I have 1 plus the square root of -2 minus 6x squared. What does it mean to square something? It means to multiply it by itself. So I need to do 1, oh, that's not a 1, 1 plus the square root of -2 minus 6x times itself. Because that's exactly what it means to square something. Now, before you look at that and feel intimidated by the fact that we're distributing with a radical, it works just like distributing with a regular old variable. All right? So I'm going to go ahead and do our first outer and last distributive property. 1 times 1 is 1. 1 times the square root of -2 minus 6x is the square root of -2 minus 6x. The inner multiplication, notice, is going to be the same thing. The square root of -2 minus 6x times 1 is another square root of -2 minus 6x. Right? Just think of it as if it were an x. If this were, instead of some big complicated radical, if this were just an x, wouldn't you say, oh, 1 times x is 1x, right? 1 times x in the middle is 1x. Since it's just this radical, it doesn't mean everything is suddenly changed. We can just go ahead and say, well, we have one of these and we have another one of these. Now I'm faced with the last multiplication of the square root of -2 minus 6x times the square root of -2 minus 6x. Just to make a little side note over here, this is what we're really working with now. I got to push my keyboard out of the way. We got the square root of -2 minus 6x times the square root of -2 minus 6x, right? Really, what we have there is the square root of -2 minus 6x times itself, or in other words, the square root of -2 minus 6x squared, right? the square and square root cancel out, and that really just gives us negative 2 minus 6x. It's like saying if I had the square root of 7 times the square root of 7, well, that's just equal to 7. If I had the square root of 11 times the square root of 11, that's just equal to 11, because it's the square root of 11 squared. The same thing occurs here. The square root of negative 2 minus 6x times the square root of negative 2 minus 6x is negative 2 minus 6x. And that's all equal to 1 minus 8x. Okay. Again, if you do have a question at any point, feel free to unmute your mic and speak up or type it in the chat, and we'll definitely get back to you. All right. Going forward from here, I definitely want to clean up that left side a little bit by combining some like terms. Here I have a 1 and a minus 2, so that's negative 1. Minus 6x doesn't really combine with anything else over here, so we're just going to leave it alone. And now notice I have one square root of negative 2 minus 6x and another square root of negative 2 minus 6x. So altogether, that's 2 square roots of negative 2 minus 6x. It's just like if you had x plus x, you would write 2x. Well, I have the square root of negative 2 minus 6x plus the square root of negative 2 minus 6x, though that makes 2 of them. And that's equal to our right side, which hasn't changed yet, of 1 minus 8x. Now, if you've noticed, what I've done is I've taken my 2 radical problem and I reduced it down to 1 radical. So I want to just isolate that radical and square both sides again. So I'm going to do exactly that. I'm going to add 6x to both sides. I'm going to add 1 to both sides. We get 2 times the square root of negative 2 minus 6x is equal to 2, that's 1 plus 1, and then minus 2x. Okay? Now that we've reduced our problem down to 1 radical, there's a very important note that I want to make that helps to make your life a lot easier. It's important to pay attention to this coefficient right here. Yes, I could now just go ahead and square both sides, but actually it makes my life a lot easier to divide everything by 2, because you notice that everything is divisible by 2. That won't always be the case 100% of the time. You may get some problems where it's not divisible, and you'll just have to deal with having that coefficient there. But I just want to make a little note for you to note that if it is possible to divide by the coefficient of the radical evenly, then just do it. Right? So again, that's not something that will always be possible, but in the case that you find that that is a thing that exists, or if that is the case, then go ahead and do it, because it's really going to just benefit you from working now with smaller numbers. I'm going to go ahead and divide both sides by 2. I now get the square root of negative 2 minus 6x is equal to 2 divided by 2 is 1. 2x divided by 2 minus 1x. Okay. Any questions, comments, concerns about that? Because now, this is a problem that we should all be very familiar with. This is a problem where I now just have to square both sides, do a little bit of distributing on that right side, and solve. Right? So let's do exactly that. I'm going to square both sides now to eliminate my last radical. Negative 2 minus 6x is what we get on that left side. And that's now equal to, we just have to do a little first, outer, inner, last, 1 minus x times itself. Applying the distributive property, I have negative 2 minus 6x is equal to 1 times 1 is 1. 1 minus x is minus 1x. Another minus 1x in the middle makes minus 2x. And then negative x times negative x is positive x squared. Okay. Once again, when you see that value of x of positive x squared, that's an immediate indication that we have to set up to factor. Immediately. Immediately. Okay? That should be like an alarm that goes off in your head that's like, ooh, I definitely have to factor. So we're going to do that. But before we factor, of course, we have to set equal to 0. So I'm going to add the 6x over to this side. I'm going to add 2 over to this side. And I'm just going to rearrange those like terms on the right, or rearrange those terms on the right side so they're in a familiar order. X squared plus 4x plus 3. That's a prime time factoring problem. That now gives me 0 is equal to. We need x and x to go ahead and make x squared. I notice that everything is positive, so it makes a lot of sense to keep all the signs positive. And now we're just looking for some combination of numbers that multiplies to this 3 and can combine to give us the 4 in the middle. That's just 3 and 1. And so I end up with two potential solutions, one of x equals negative 3 and one of x equals negative 1. I say potential solutions because we still do have to go back and check for extraneous solutions. But I just want to give a couple seconds to say, does anybody have any questions? If so, please don't be afraid to speak up. All feeling A-okay so far. Okay, I take your silence as I feel fantastic about this. All right, great. So one other thing to keep in mind, again, is we do have to check for extraneous solutions. I know when you're looking at a problem like this, a problem that fills up almost an entire page, you're like, it can be very intimidating, and I totally understand that. But none of these steps, I don't think, are beyond what you have already learned how to do. It's just a lot of steps put together in a row. It's squaring both sides, distributing with a radical, which we've done problems like that before, combining like terms, isolating the radical, just dividing if necessary, and then we get down to a familiar problem that we worked with yesterday. I would square both sides, distribute on the right, combine like terms to set up to factor, and do some factoring at the end. All right, let's do our last final check for extraneous solutions. Let's check when x is equal to negative 3. Is it true that going all the way back up to the top and plugging in negative 3, 1 plus the square root of negative 2 minus 6 times negative 3, is that equal to the square root of 1 minus 8 times negative 3? And I believe it is. Here I get 1 plus the square root of 16, so that's 4, so 1 plus 4 is 5, is equal to the square root of 25, and yeah, absolutely 5 is equal to itself, so I'm very happy with that. X equals negative 3 is a valid solution. We got one more to check. Let's check. When x is equal to negative 1, is it true that 1 plus the square root of negative 2 minus 6 times negative 1 is equal to the square root of 1 minus 8 times negative 1? Is that true? Well, 1 plus the square root of, let's see, this is positive 6. Negative 2 plus 6 is 4. I got 1 minus negative 8 times 1, and that's going to be 1, that's going to be 9. Very good. So I have 1 plus the square root of 4 is equal to 9. That's definitely true, right? 1 plus 2 is equal to 3. We're happy with that. And so this problem has two valid solutions, one of x equals negative 3 and the other of x equals negative 1. All right. Again, if anybody has any questions, just feel free to shout it out or type it in the chat, and we'll definitely get back to you. No questions, comments, concerns, it seems like. All right. I know that problem took a while. I want to show you one more problem like that. I'll go a little bit faster this time. We got on the back side already ready for you here. Okay. All right. So doing another problem just like that. Let's go ahead and take a look at this. No, these problems are both going to work out differently, which is why I definitely want to show you both cases. One actually towards the end where you can divide by that coefficient, and this one you're going to see that we can't really divide by that coefficient, but that's okay. We'll make the most of it. I promise we'll get through it. All right, so starting with this, same deal as before, impossible to isolate both radicals simultaneously, so I just have to square both sides and work with what I got. Right? On that left side, I'm going to square negative 1 plus the square root of negative 2 minus x by multiplying it by itself. We got negative 1 plus the square root of negative 2 minus x times itself. Negative 1 plus the square root of negative 2 minus x. And that's going to be equal to, on the right side, it's nice and easy. The square and square cancel out. I get negative 6 minus 2x. Now we got a little first outer inner last going on, the distributive property here. Negative 1 times 1 is positive 1. Negative 1 times one of those radicals is exactly that. Negative 1 of those radicals. Negative 2 minus x. Think of, again, if it were just negative 1 times x, you would write negative 1x. It's the same deal. Inside we get the same thing, notice, minus the square root of negative 2 minus x. Plus now, we got the square root of negative 2 minus x times the square root of negative 2 minus x is exactly that. We get negative 2 minus x. Okay? And again, that's all equal to this side of negative 6. minus 2x. Any question about that? Again, I think that distribution part is definitely the part where a lot of students make the most mistakes. I think that's the most error-prone part of all of this. So going forward from there, again, I'm going to combine like terms over here to clean up this left side. We have 1 minus 2. That's negative 1. I have the negative x, which can't really combine with anything. So see this 1 minus 2. This negative x can't really combine with anything, so it just kind of stays by itself. And now I have negative 1 of these and another negative 1 of these. So altogether that makes negative 2 of the square root of negative 2 minus x, which is equal to negative 6 minus 2x. Alrighty. Now I'm just going to go ahead and isolate that radical by adding the x over to here and adding the 1 over to here. Something that I want to note is that a very, very common mistake that a lot of students do is to combine like terms, or quote unquote combine like terms, on the left side by combining this this negative 1 with the negative 2 here and making this a negative 3. That is absolutely not the case, but it is a very tempting mistake to make. This is one collective term. It's just like if I had 1 minus 2x. You wouldn't combine that, or sorry, negative 1 minus 2x. You wouldn't combine that to be negative 3x, right? Those are unlike terms. You definitely wouldn't do that. You would just leave it alone. You can't really simplify that expression. The same thing is true here. It's very tempting to pull that number and combine it with the negative 1, but this is glued to this, just like how you would see in a regular old variable. So I'm now left with negative 2 times the square root of negative 2 minus x is equal to negative 6 plus 1 is negative 5. Negative 2x plus 1x is negative 1x. Unfortunately, as I kind of hinted at the start of the problem, we don't see any divisibility going on here. If I divided both sides by negative 2, we would end up with fractions. So it's much easier to just leave it alone. We will just have to deal with that coefficient there, but we can do that, no problem. Square it. Square it. Now, you may be wondering, how am I going to square something like negative 2 times the square root of negative 2 minus x? Well, this is multiplication here. We have negative 2 times that square root of negative 2 minus x. It's just like, I'll do this over to the side, what if you had this, negative 2x squared? What I would do is I would square the negative 2 to make a positive 4, and I would square the x to make x squared. Right? When you have multiplication, you have a monomial, just one single term. You can square each component of that term because that's how multiplication works. It's very different from something like negative 2 plus x squared. In that case, now we have a binomial. We have to multiply that by itself by doing negative 2 plus x times negative 2 plus x. Right? So just FYI, when you have multiplication, it's much easier to square. We don't have to write that out twice. I can just say this is negative 2 times negative 2, which is positive 4. The square root of negative 2 minus x times itself is negative 2 minus x. And that's all equal to now. We have to multiply this by itself, though, and do some distributing like that. Okay? Any questions about that? Hopefully feeling all right. Hopefully feeling good. Okay, fantastic. Now I can distribute this 4. I get negative 8 minus 4x. Again, just interrupt if you do have a question, though. Don't feel like you're cutting me off or anything. I'm here to help you. We get negative 5 times negative 5 is positive 25. Negative 5 times negative x is plus 5x. Notice I have another plus 5x from this inner multiplication, so that's going to make plus 10x. And then negative x times negative x is positive x squared. I see that x squared. That's, again, another alarm that goes off in my head that's like, I need to factor this. But in order to factor, I, again, need to set equal to 0. So I'm going to do exactly that by adding 4x to both sides. And I'm going to add 8 to both sides. And I get that 0 is equal to, again, just rearranging these to be in a familiar quadratic standard form. We get x squared plus 14x plus 33. We can now factor that down. Again, a little factoring refresher. We need x and x to generate x squared, because x times x would be x squared. Everything's positive up here, so it makes sense to keep everything positive down here. And now we're looking for factors of 33. that when we multiply like this, we're going to get this 14x in the middle, and I believe that's just 11 and 3. Okay. Once again, that gives us two potential solutions, one of x equals negative 11 and one of x equals negative 3. Potential solutions, again, because we do still have to check. Any questions, comments, concerns about that? All right, let's check for our extraneous solutions. Then we'll have just about 5 minutes, maybe a little bit more at the end of class, if you have any questions about those previous 3 questions that were on the assignment scheduled for completion today. So let's check when x is equal to negative 11. Is it true, again going way back up to the top, that negative 1 plus the square root of negative 2 minus negative 11, is that equal to the square root of negative 6 minus 2 times negative 11? Is that true? Well, let's find out. I get negative 1 plus the square root of negative 2 plus 11 is going to be 9, is equal to the square root of, let's see, what do we get here, 16? So is negative 1 plus 3 equal to 4? I don't like that. Ugh. Gross. Don't like that at all. Definitely have to consider this as an extraneous solution, right? Which is somewhat unfortunate after all that work. But just like yesterday, or last class, I'm going to say yesterday, it was, what, Wednesday? All hope is not yet lost because we still have one possible solution. Let's find out. For when x is equal to negative 3, is it in fact true that, going all the way back up to the top again, negative 1 plus the square root of negative 2 minus negative 3 is equal to the square root of negative 6 minus 2 times negative 3? Okay. Let's find out. We get negative 1 plus negative, the opposite of negative 3 is positive 3, so here I get the square root of 1. Is that equal to, oh, that's just the square root of 0. That's definitely true, right? Negative 1 plus 1 is equal to 0. So we do, in fact, have one real solution, and that solution is x equals negative 3. Keep in mind that it is possible that after going through all of this, you could have checked both solutions, and they both could have been extraneous, in which case you would say that the problem has no solution. A little disheartening after going through all this work to only find out it has no solution, but still a thing that can happen. All right. So those were the 2 problems that I wanted to show you today. Does anyone have any questions at all? I'll give you about 30 seconds to process all of that. See if you have any questions. Again, you can unmute yourself and just speak up, or you can just go ahead and type in the chat. Either way is totally fine. But I'll give you about 30 seconds of processing time. Again, looks a little intimidating, but just taking it one step at a time, it's definitely doable. Definitely doable. And this is the hardest these radical equations will get, by the way. There's not like there's no super advanced category. This is beginner, intermediate, and now we're on advanced. Okay? Oh, Maddie asked, was there attendance posted for today? Yeah, it's the same form in Google Classroom. If you could just go ahead and fill that out, that would be great. Okay, it's the same one as last class. There's no reason to reinvent the wheel. We're not just going to keep creating more and more forms that do the same thing. Just use that same form every day. That should be fine. Same reason we're just using the same link for a Google Meet every day. Great question, though.
Can you go over number 2 on the practice problems real quick?
Absolutely, Paige. I'd be happy to do that. Any other questions on this before I transition to the practice problems? I'm looking for another piece of paper nearby. Okay, we got one right here. All right, yeah, let's go over number 2 on the practice problems. Okay, go with some plain white this time. All right, so on the practice problems, number 2 was just a cube root problem, right? So we had, this was on the practice problems, the cube root of 9x minus 10 is equal to 5. Since this is a cube root, what I want to do to both sides in order to get rid of the cube root is to cube both sides, raise both sides to the 3rd power, right? Because the cube root and cube will cancel out. It's very important to match the power of the, or sorry, match the index of the radical with the power that you raise both sides of the equation to, because I feel like a common mistake a lot of students do is they just get in the habit of squaring every time. Every radical they see is square root. But keep in mind, this is a cube root. We do have to cube both sides. I get 9x minus 10 is equal to 5 to the 3rd, which is 125. That's 5 times 5 times 5. I can add 10 to both sides. This is now just Algebra 1 land. Add 10 to both sides. You get 9x is equal to 135. You can divide both sides by 9. And, quick maths. 135 divided by 9 is something. It is, oh boy, you do it off to the side real fast. Look at this, good old long division coming back, right? 15. Nice. Now, just like before, we do have to check for extraneous solutions. As always, let's check. When x is equal to 15, is it true that the cube root of 9 times 15 minus 10 is equal to 5? And I believe that's definitely true. 9 times 15 is our 135. Minus 10 is the cube root of 125 is equal to 5, which is true. So this works out. Paige, did that help?
Yes, thank you.
Excellent. Fantastic. Any other questions? I'm checking the chat right now. Could you do this first one? Not the solving, just the graphing, says Maddie. Yeah, absolutely. So the first one, if you notice, requires a little bit of simplifying before you can actually get to grips with it. So the first one starts out with this. Let's just create a little divide here. We got f of x is equal to negative 2/3 times the cube root of 27x plus 54 and then plus 4. I'll just go through the simplification process with you. So since this is a cube root, what we can do is we can look for a GCF on the inside, and hopefully that GCF is a perfect cube. In this case, it most certainly is. I can, instead of jumping right in and making my life very miserable working with those numbers, we could say that this is negative 2/3 times the cube root of 27 times x plus 2, right? Taking out a GCF of 27 because 27 times 2 is 54. Now, since you have the cube root of 27 times x plus 2, you can really split that apart to be negative 2/3 times the cube root of 27 times the cube root of x plus 2, and then plus 1. Plus 4. The cube root of 27 is just 3. That's the benefit of doing that, is you can now look at that and be like, ooh, the cube root of 27, I can simplify that to 3. So we get negative 2/3 times 3 times the cube root of x plus 2 plus 4. And if you notice, the 3's will cancel out, just giving you negative 2 times the cube root of x plus 2 plus 4. And at that point, that should definitely be a function that you can go ahead and graph by creating a chart and looking for your perfect cube goals. All right. Maddie, was that helpful? And everybody, was that helpful, hopefully? Okay, very fantastic. Very good. Any other questions or concerns? We have just about 1 minute to go left in this class. Give you some thinking time. Let you soak it all in. I'll put the notes back up there if you see them. We have this problem. Very good. Okay, so that being said, next class I will have a couple practice problems posted on Google Classroom for you to do. I did probably about 2 problems like these because I know they take a long time, so maybe 1 like the ones we've been doing before and then maybe 2 like this. I think that's certainly more than fair. That will be due on Tuesday because that's the next time that we see each other. One thing that I want to mention is, again, make sure you fill out that attendance form, as Maddie reminded us all. It's on Google Classroom. It's the same one. We're going to use the same one every day. The video for last class's lesson, which was Wednesday, is posted on Google Classroom. I meant to post it way earlier, but Google Classroom was giving me some difficulties with posting stuff. I know yesterday was kind of a technical snag for some people as well as the day before, but it should be all up and running now, so please go ahead and check that out if you need to. You can go ahead and check it's like so weird to say it. You can go ahead and check my YouTube channel, but that's what you can do. I'm posting all the lessons up on YouTube, so please feel free to go ahead and stop by. If you want another explanation for this, I'm doing the same explanations during period A1, so you can watch those if you so desire, but that's what you got. All right. Please make sure you complete those practice problems. It's really critical that you do that so you can stay on top of everything we're doing. If you have any questions, you can feel free to reach out to myself or Miss Mao. Miss Mao, I don't know if you have anything to add, but that's pretty much all I got.
So it's super important to do the practice and get feedback from either one of us, right? You know, this is like a tough time of learning, but we're all learning together, so yeah.
Good. Yep. Couldn't have said it better myself. Thank you so much. All right. Thanks, everyone. Have a fantastic rest of your day and a great last period. Thank you. Go ahead and stop recording.